Well, first, I would like to make a comment about the golden record. I think it was presumptuous of us to send it because there is no reason for us to brag about our cultural accomplishments. That would be of no interest to extraterrestrials. We are probably representing one ant out of many ants on the sidewalk of the Milky Way galaxy. We're not special or unique or particularly interesting. And for us to assume that if we send out a list of our accomplishments, of our characteristics, I think it's presumptuous.
Hello, space enthusiast. You're now listening to Space Forward Podcast. In this show, we explore with leading space scientists, experts, and professionals about why and how humanity can achieve a multiplanetary presence within our lifetime. I'm Hussein Bukhari, your host. Tune in now for finding intelligent life in the cosmos with Professor Avi Loeb.
Recently, Richard Branson and Jeff Bezos used their wealth to lift their body by 1% of the Earth radius. And they were very proud of that accomplishment. But the size of the observable universe is 10 to the power 19. And if you think about space, showing off is an oxymoron. You cannot show off by lifting your body by 1% of the Earth radius when the observable universe is 10 to the power 19.
In this episode, we talk to Avi about what he thinks we might find in the observable universe. Will it be biosignatures that will reveal extraterrestrial life? Or technosignatures, evidence of a past or present alien technology? I'd like to welcome Kelly Kowalski, an International Space University fellow alumni. She'll be joining myself, Matthias Frenzel, and Benjamin Shapiro as we move forward with Space Forward. Booyah! Kelly, nice to have you with us.
Thanks for having me, guys. And I'm super excited to talk to, you talk to him, your next guest, Avi Loeb, the Harvard professor who says we might have actually had a UFO shoot through our solar system.
It's something interstellar, definitely.
An interstellar object of unknown origin. But how the heck do you say it?
It's Oumuamua. It's a Hawaiian word, actually. It's called message from afar.
I heard scout was another word that was used.
It could have been. I mean, Avi mentioned it to me the first time, and I was like, is it really, though?
Well, why don't you tell our listeners what Avi is all about? What is his background? What is his credentials? Because it's kind of crazy that he talks about UFOs or UAPs or interstellar visitors, and we might put off some of our listeners.
Yeah, so he's actually a theoretical physicist, astronomer, and Frank B. Baird Jr. Professor of Science at Harvard University. He directs the Black Hole Initiative and the Institute of Theory and Computation there. He's also a member of the President's Council for Advisors on Science and Technology, chairs the Advisory Committee for a Breakthrough Starshot Initiative, and he's on the board of Physics and Astronomy of the National Academies. And guess what? He's authored over 700 scientific papers.
And a lot of popular science books, like the one I'm reading right now, Extraterrestrial, the First Sign of Intelligent Life Beyond Earth.
You know, I read that one, or actually I listened to it. It was phenomenal, actually. And he's also done a recent academic textbook, Life in the Cosmos, from Biosignatures to Technosignatures.
Okay, so as I understand it, biosignatures are those chemical markers that scientists look for to theorize that maybe an exoplanet could harbor life.
Yeah, at least life as we know it.
Right. And technosignatures, these are potential markers of technology perhaps made by some kind of intelligent life form. And real scientists are really looking not for some kind of Hollywood YouTube UFO phenomena, but real signs of potential alien life elsewhere in the cosmos.
Oh yeah, you definitely got it there. So get ready, because we're going forward in space with Professor Avi Loeb. Avi, it's great to have you. You've just recently published a new book, A Life in the Cosmos, together with Mansavi Lingam. It's a tremendous overview of exoecology. and from the origins of life to the propagation of life in universe and technosignatures and life detection. We had a lot of aha, which is that's the way that it works. And now I understand moments while reading the book. When was your first last wow moment when you suddenly discovered the solution to a problem that had been perhaps nagging at you for years?
Well, thank you for hosting me. This is a textbook of more than 1,000 pages that we hope will be useful to the research community. And the special quality of this textbook is that it involves both the search for primitive life, microbial life, as well as the search for intelligent life. And obviously, if we find microbes on Mars, we can still feel pretty good about our superiority relative to them. It doesn't hurt our ego very much if perseverance tells us that there used to be microbes over there. But if we find a piece of technological equipment and we press its buttons and it looks like it does things that our technologies were not able to do as of yet, that will be a strike to our ego. On the one hand, microbial life may be more abundant. It may be in many more places because it's more primitive and it's easier to accomplish. But at the same time, the signals or the signatures of technological life may be more prominent. We could see them to greater distances, or we could find the relics of them floating in space near Earth. Equipment like Voyager or New Horizons that we sent out of the solar system may be abundant. There may be civilizations that predated us by billions of years, and we could find equipment that they send into space. And we better know whether we have neighbors and whether there are smarter kids on our block. And I would think that, the search for intelligent life should be more mainstream than it is right now. And that was the purpose of the textbook, to bring in that subject together with the search for microbial life, because it's not clear what we will find first.
So when was it that you get this idea to look for technosignatures in the first place?
Right. It was in October 2017 when the first object from outside the solar system was discovered near Earth, and it was given the name Oumuamua because the telescope that discovered it was Pan-STARRS in Hawaii. And this name means a scout or a messenger from far away. And the reason it was quite intriguing for me is because I wrote the first paper a decade earlier forecasting how many rocks we should expect from other stars. If you just assume the same abundance of rocks as we have in the solar system and some of them being ejected, you can calculate how many rocks we should expect to come from outer space. And we forecasted that this telescope would not find any by a very large margin, somewhere between 100 to 100 million less abundant than necessary for that telescope to detect something. And yet it found an object. So that was to me quite intriguing because my calculations turned out to be wrong. There was this object, and of course I assumed that it's a rock. But then as time went on, the properties of this object didn't look like the rocks we have seen before in the solar system. It didn't have a cometary tail. There was no gas or dust around it the way comets have. So it was definitely not a comet of the type that we have seen in the solar system before. And it was also not a bare rock, an asteroid, because as it was tumbling, it changed the amount of sunlight reflected from it by a factor of 10. And that meant a very extreme shape, most likely flat, pancake-like. And then it was also pushed away from the sun with a force that declines inversely with distance squared. And the only way I could make sense of it, since there was no evaporation, was the reflection of sunlight. And actually, turned out that in September 2020, there was another object discovered that exhibited an excess push away from the sun and no cometary tail, and it was given the name 2020 SO. It was found by the same telescope. And this object ended up being a rocket booster from a 1966 mission to land on the moon. And we know that we produced it, and it had very thin walls that made it have a large area for its mass, so it could be pushed by reflecting sunlight. And that illustrates the point that you can tell the difference between a rock and an artificial object. The only question is who produced Oumuamua. So a year later, I published a scientific paper suggesting that perhaps it was produced by an artificial technological civilization. And the paper was accepted for publication within a few days. And then there was a huge amount of interest in it from the general public. And the scientific community had pushback, was reluctant to discuss this possibility. If you ask me for a kind of milestone for my discussion on the possibility of life elsewhere, this was it.
It's strange that a 1966 rocket booster is still floating in space.
Yeah.
I mean, I guess there's a lot of space junk or space artifacts, depending on how you look at it, that are still up there floating around. But I guess in the case of Oumuamua, it's interstellar, so it's not our space junk, right?
Yeah, I mean, the jury's still out whether Oumuamua was a natural or artificial object. We can only theorize based on, the data that's collected.
So Oumuamua was reflecting light by a factor of 10, meaning it was brighter than your average space rock, but also super flat, like a pancake, and tumbling so the light was kind of flip-flopping at extremes. But I guess what was also weird was that it whipped around our sun and sped up as it left the solar system.
Yeah, and in order to explain this acceleration, Avi theorized that Oumuamua needed to have high area and a low mass. As he says, flat and thin like a pancake, so that it could be easily propelled by the photons from the sun.
Like a solar sail.
Well, I mean, we don't know for sure, but Oumuamua's configuration hasn't been seen before, not really natural. So Avi's conclusion that it must be artificial. So I had to ask him about the possibility of extraterrestrial self-replicating von Neumann probes.
Right. Artificial intelligent self-assembling machines sort of spreading out throughout the universe. Tiny, fast, and prolific. All right, so let's get back to Avi.
So do you think that a next generation golden record 2.0 should just be self-replicated von Neumann probe, spreading itself isotropically and exponentially in the universe, containing human knowledge, essentially? Do you expect an extraterrestrial intelligence would have done something similar?
Well, first, I would like to make a comment about the golden record. I think it was presumptuous of us to send it because there is no reason for us to brag about our cultural accomplishments. That would be of no interest to extraterrestrials. We are probably representing one ant out of many ants on the sidewalk of the Milky Way galaxy. We're not special or unique or particularly interesting. And for us to assume that if we send out a list of our accomplishments, of our characteristics, anyone would be interested in checking this out, I think it's presumptuous. And let me give you another example where we are proud of an accomplishment that makes little sense. Recently, Richard Branson and Jeff Bezos used their wealth to lift their body by 1% of the Earth radius. That's basically what they did. 1% of the Earth radius. And they were very proud of that accomplishment. But the size of the observable universe is 10 to the power 19 bigger than the Earth radius. And if you think about space, showing off is an oxymoron. You cannot show off by lifting your body by 1% of the Earth radius when the observable universe is 10 to the power 19. Now, what can you be proud of? You can be proud of producing an AI system, an artificial intelligence system that is behaving like a kid. With your kids, you educate them, you provide them with a blueprint for life, and then you send them out to the world and they interact on their own. They learn from experience, just, in the context of AI systems, it's called machine learning. So they can learn from their experience.
What is this blueprint of life that we're going to share, and who's created it?
Yeah, so I think we could be very proud if we produce AI systems, we educate to do what we think is important. Like, for example, we can give them the DNA information of forms of life on Earth and ask them to reproduce what we find precious on Earth, like various forms of life, on other planets, so we can send them elsewhere. Now, it will take a long time for the journey. If you send them with a chemical rocket, it takes 1 million years to traverse 100 light years. So it's a long time, but it takes less than 1 billion years to go around the galaxy. And 1 billion years is much less than the age of the Milky Way galaxy. So in principle, other civilizations that predated us by 1 billion years could have done it already. And my point is, we should be very proud of AI systems equipped with 3D printers being sent out as if they were our kids. I have no problem being proud of an AI system, just like I'm proud of my daughters if they perform well. And I would send them out. There is no reason to send humans to space, to interstellar travel, because they would not survive the journey. Everything you see in science fiction makes zero sense. For humans to be on a spaceship that travels between stars, that makes little sense, because within 1 year, the exposure to cosmic rays without the protection of the Earth magnetic field and atmosphere, just the exposure to cosmic rays would kill a substantial fraction of the cells in your brain. And Darwinian evolution did not select us to survive in space. It selected us to survive on the surface of the Earth.
Yeah, but the Darwinian evolution didn't take into account that we would ever go into space. I mean, it wasn't even a precursor to that thought process. So can we fundamentally say the time of Darwinian evolution has ended and this is a new version?
No, so that's exactly my point, that we arrived at the qualities we have through evolution on the surface of the Earth. And as a result, our qualities provide a good fit to those conditions. For example, our eyes are sensitive to visible light just because the sun emits visible light. If we were to live next to a star like Proxima Centauri, which is the nearest star to us, 4 light years away, it's a dwarf star. Most of the stars in the Milky Way galaxy are smaller than the sun. And that star has a surface temperature that is half of the surface temperature of the sun. So it emits mostly infrared light. And our eyes would be infrared eyes. They would be very different than the eyes we have. I actually asked students in my class if they know of any animal here on Earth that has eyes that are sensitive to the infrared. And one of them found a shrimp that has infrared eyes, and they look like ping pong balls connected with cords to the head of the shrimp. And frankly, this animal looks like an alien to me.
So here's a question. Would you eat that shrimp because it looks like an alien to you? I'm very, very curious. But because it's a shrimp, but it also has the composition of what we define as, well, what we're currently defining as an alien.
Well, I wouldn't eat that shrimp because I was raised on the Jewish tradition, and you don't eat shrimps.
Okay.
But putting that aside, the question of whether we speak or eat the aliens when we meet them, I think is completely secondary, because I think there is a very small likelihood that we will ever meet in the near future a biological creature that comes to visit us, because I think equipment survives the long journey between stars much better. So that's why I was talking about AI systems, because you can build the electronics that will survive for 1 billion years and reach destinations where it could be even smarter than humans. AI systems are currently driving cars. Within 10 years, they will make medical decisions, life and death decisions for us. So I think we should be very proud of them, just like a smart kid. And why would we try to send something that was not designed for space travel, like humans or biological creatures? We will not do that. And for the same reason, other advanced technological civilizations would not do that. Or if they try to do that, these creatures would not survive the journey, because the journey is very long. So my point is, if we establish contact, it's most likely to be with equipment. And we should be ready for that. So here is another point, that if we meet AI systems of others, we might need our own AI systems to interpret the meaning or the intent of those AI systems, just like relying on your kids to tell you, to interpret for you content that you find on the internet, because the kids are more computer savvy.
Okay, first off, I'm really not for eating alien meat, or any meat for that matter. Although it would be really cool to have artificially constructed meat and AI was the cook.
We're probably more likely to bump into extraterrestrial AI cooks rather than shrimp looking like aliens.
Okay, so maybe not biological aliens, and instead a message in a bottle?
A message that we may or may not be able to decode.
Either way, a message in a bottle, an alien artifact, I just see it as having a profound effect on humanity. Like, I guess when those Apollo astronauts snapped that photo of Earth and we learned just how fragile this planet is and perhaps how lonely we humans are in the universe.
I think the question of whether we are alone and whether there is a smarter kid on the block is the most important question that science can address in terms of its implication for society, because it will change our perception about our place in the universe and will change our theological beliefs and philosophical beliefs. It will also change our relations with each other because, if you look at human history, much of it was shaped by the desire of some humans to feel superior relative to other humans. Just look at the Second World War. 75 million people died, which is huge, even compared to the COVID pandemic right now. It was 3% of the world population that was killed in a single war that was motivated by the Nazi regime trying to feel superior relative to other people. And they killed 2/3 of the Jewish population in Europe, 6 million. The US had to invest $4 trillion in that war. And you ask yourself, is that a sign of intelligence? Probably not. So our civilization is marked with attempts of people to feel superior relative to each other and wasting a lot of resources on that task. But if we found another civilization far more advanced than we are, it will make our differences so small and meaningless that I hope people will come together because we are part of the human species. And we will perhaps try to understand how, what is their message? What do they think? And I very much hope that this would have a positive impact on our society. But at any event, there is no other question that is bigger than that. We know that roughly half the stars like the sun have a planet the size of the Earth, roughly at the same separation. This is from the latest data from the Kepler satellite. And given that information, if you arrange for similar circumstances under tens of billions of other planets within the Milky Way galaxy alone, you might as well get similar outcomes. And, most of the stars predated the sun by billions of years. And so a civilization like ours, or a little more advanced than ours, could have sent out artificial intelligence systems equipped with 3D printers that pretty much fill up the entire Milky Way galaxy and with probes on every habitable planet, because you can send self-replicating probes. And, it's sort of like, if you think about it globally, it's just like Darwinian selection, except extended beyond biology. So systems that can travel across large interstellar distances, like AI systems, and survive for billions of years, are far more superior. They are the fittest to survive in the long term, much more so than humans or biological creatures. And in the long term, over billions of years, they might be the most abundant, if indeed they are produced by even one civilization that predated us. So my point is, we should be modest. We shouldn't assume that we are the smartest, that we are alone. And by the way, we've been searching for 4 decades for the nature of dark matter. We don't know what it is. So back when I started astrophysics, in the 1980s, the prevailing idea was that the dark matter is made of weakly interacting massive particles. And there were hundreds of millions of dollars spent on experiments attempting to detect weakly interacting massive particles without success. I'm not saying it's a waste. It was part of the mainstream. It still is. And I asked an experimentalist, how long will you continue searching in the dark for this type of particle? And he said, as long as I'm funded. There are all kinds of phrases. There is also the phrase that Carl Sagan, and people hang to it religiously, that Carl Sagan made, which is extraordinary claims require extraordinary evidence. Well, here is my point. They require evidence, not extraordinary evidence. Like, if you ask for the evidence to be extraordinary, and at the same time you are not funding the search for that evidence, then it's a self-fulfilling prophecy. You will never find it, which is pretty much the situation right now with the search for technological relics. It's not being funded. at a level that is 1,000 times smaller than the search for weakly interacting massive particles as a dark matter. And I ask you, why would weakly interacting massive particles be something that we believe in more strongly? I mean, after all, it was not found. I'm just saying it would be common sense to say we exist. Okay, let's look for things like us on planets that resemble our planet and things that were sent by civilizations like ours from other places. Why is that so difficult to accept?
One thing that I am very curious about personally is, do you have a routine to self-reflect and minimize the confirmation bias that could be typically carried over throughout the years of research?
Yeah, it's very simple. I don't subscribe to social media. It started when I married my wife. She asked me not to subscribe. I think she was worried about me making statements that I would later regret. That was a very wise advice that she gave me. I committed to that and I honor my commitments, when we got married. And so I never subscribed to Facebook or Twitter or Instagram or any of these. In retrospect, it saved me from the groupthink that you find there, because when you want to be liked, you're paying a lot of attention to the audience. You don't keep your eyes on the ball, so to speak. One thing I learned throughout my career is there were several instances where I advocated something that looked right to me. For example, I talked about the mass of black holes at the centers of galaxies being correlated with the characteristic speed of stars. When I mentioned it at a conference, the speaker just said, "Oh, no, it's not interesting. This should not be looked at." And then I mentioned it to two people that were on a junior faculty search that visited my office, and they looked into that. And then it became, there were two groups that wrote papers about it, and became the hottest discovery for 15 years in that field. And I thought to myself, how is it possible that it's being ridiculed and dismissed, and then suddenly it becomes the hottest thing? And then I gave a lecture about gravitational wave astrophysics at the winter school in January 2013. Again, 10 minutes into my lecture, there was another lecturer that stood up, and it's all on video. That person is 20 years younger than I am, yet he had the nerve to stand up and in front of all the students say, "Why are you wasting the time of these students on a subject that will never be important throughout their career?" 2.5 years later, the first gravitational wave source was discovered by the LIGO collaboration, and the Nobel Prize was awarded a few years ago to that. It was just 2.5 years later, and these students were not only still going through their career, they were actually doing their PhD. So this subject became the hottest subject in astrophysics, one of the most exciting frontiers where we use gravitational waves to learn about the universe, not just light, as was traditionally done for a century or so. And then when I get to the point where I say Oumuamua could have been a technological relic and it's being ridiculed, I say the hell with it. I don't care about groupthink. I don't care about social trends. I will just advocate what I think is right.
This kind of brings us to a question that we ask all of our guests. What are the steps needed for humankind to become a multi-planetary species? And in the context of all that we've discussed today, is it even worth a while venture? What can we learn from the search of an extraterrestrial technological intelligence?
Yeah, so in one of the forums that I attended, I was asked, how long do I think our civilization will continue to ignore potential evidence about others? And I said that, in principle, we can be ignorant forever. If we refuse to look through the windows, and if we claim that we are the smartest, that there is nothing like us, and we would need extraordinary evidence to look through the window, we will never find this evidence. Okay, so in principle, we can be ignorant forever unless we start to search. And that is really my main message. So I think of science as privilege to maintain your childhood curiosity. And if you ask people that knew me from the time I was a child, I haven't changed much. I'm still the same farm boy, that I grew up as. And I'm not afraid of making mistakes because it's part of a learning experience. And so if we check Oumuamua and it turns out to be a hydrogen iceberg, so what? So we learn something new, that there are nurseries of objects that we have never imagined before. So we learn something new, and the only sin that we can make is basically ignoring it and claiming business as usual, it must be a rock, forget about it, let's move on, and not collect any evidence, not search for evidence. That's the worst we can do.
So, Hussein, what do you think? Is it a worthy pursuit to search for intelligence beyond our solar system?
I mean, we need to find out what we don't know. It's embedded in our DNA as human beings and explorers, so I believe this is the best way to do it.
Yeah, I think the way technology is going and all the data we're collecting, we might be getting a little closer to actually finding something other than ourselves.
Yep. So, in our next episode, we continue our conversation with Avi Loeb, and things get more wild.
Wild or not so wild, like the idea of sending our own space probes to our next door neighbor, the Alpha Centauri system.
And we dig deeper into his latest project, the Galileo Project, taking the next step to refine the search for technosignatures.
Can't wait.
Me too. No, he's pronouncing the name correctly, so I should pronounce it von Neumann.
Neumann, human Neumann.
Von Neumann.
I say Van Neumann, you say Van Neumann.
We say von Human.